¿Qué tal? Y continuamos aquí en Yotta 2025. Y si alguno de ustedes se ha preguntado realmente si está creciendo las soluciones en inteligencia artificial para poder enfriar servidores, hoy tenemos la oportunidad de platicar con uno de los fabricantes que está haciendo mucha evolución en este sentido, ha hecho presentaciones. Yo estamos con Shahar Belkin. Shahar, thank you for your time.
Thank you for coming here.
Yeah. Can you explain us a little bit more about the liquid cooling solution that you have available?
Yes, the last few years, GPUs and silicon has become very, very hot, very high power. We see that the silicon is becoming more and more called heat density. And in order to cool it, you need a better solution to cool it. A few years ago, you can cool chips with air. You can just have a fan going with air above it and take the heat with it. Then came the direct-on-chip liquid cooling, the cold plate with single phase, with water. So water would go through the cold plate, heat up, and take the heat with it.
Mm-hmm.
That is already coming to the end of the capability because chips are now becoming even hotter. 2,000 watt per chip we have next year.
2,000 watts
for one chip.
for one chip.
It used to be the 500 watt for one server. Now we're talking about 2,000 watt for one chip.
2,000 watts por un chip.
Yes.
Es lo que tenemos.
And if you would want to cool that with single phase water, you will need to stream 4 liters every minute into the cold plate, meaning 1 gallon per minute going through the cold plate. That is almost physically impossible. Okay? That's why the industry is moving to 2-phase. 2-phase meaning liquid comes in, it boils inside. The boiling process is taking the heat, turning the liquid into vapor. That's called phase change, and that's the strongest physical way of removing heat. Okay, it's not heating up the liquid is changing phase to vapor. Vapor is going out from the cold plate into the red tubes and going to a condenser that turns it back into liquid and brings it back into the cold plate. Very simple closed loop, nothing is lost, and the heat is actually moved from the chips themselves to the condenser and released to the air or to the water, depending what kind of condenser you are using.
Awesome. What's the temperature that we have that we can handle in this type of solutions?
Okay, the limit of the temperature is the chip themselves. Chips can go only to a specific temperature. Like the NVIDIA chips here are allowed to go only to 85 degrees Celsius.
85 degrees Celsius.
Yes.
Okay.
We want them to be as close as possible to 85, but not overcome it. Because if they go over 85, they will throttle down and stop working. So why do we want it to be very close to 85? Because the hotter there are, the hotter the vapor comes out, and it is lower cost to cool it. You can actually take the vapor outside the building, use a condenser that is called dry cooler with the air outside, and even in Mexico at 40 degrees Celsius air, you can still cool the vapor if it's 50 degrees. So what we're seeing now is about 50-55 degrees vapor coming out, cooled by air and coming back as liquid. And you can see this is about 50 and this would be about 40.
Okay, let's go and see. Vamos a ver acá también parte de lo que tiene para que conozcamos lo que se llama el cold plate, ¿no? Que se maneja. Okay.
These are examples by manufacturers, mainly in Taiwan, that manufacture their servers with our cold plate. So this is an example of the latest AMD CPU, used in a server by Compal and sold into HPC, high power computing, where the racks are very, very dense and they're all cooled by liquid. And it is very simple because you would never go to a higher temperature. In these kind of servers, without the liquid cooling, you can only go to chips of 200 watts. Because this one, if air comes this way, this one heats up the air, this one will be too hot. Okay? In this solution,
Está algo pesada, la verdad.
in this solution you can go to chips up to 400 watts without any one of them being heated up. They all are at the right temperature all the time. Other examples here, for example, from a company called SRock in Taiwan. They manufacture these servers with GPUs and network switches. Everything is with cold plates and heat is being removed by the two red tubes, and liquid comes back by the blue tube. This is not working, so it's not getting hot.
Okay.
Same thing from Compal. The difference between these two, this is using the latest NVIDIA chips. This is using the latest AMD chips. Okay, these are GPUs. These are the GPUs that are being released by AMD that is competing with NVIDIA.
Ok. Muy bien. Pues aquí vemos una alternativa más sin usar agua. We don't use water, right? This is a waterless liquid cooling solution. Y aquí estamos observando una de las alternativas que se están exponiendo en Yotta 2025 para poder dar beneficios al uso y el incremento de inteligencia artificial. Any benefits that you see from your solution, just to finish the interview?
Well, you said it waterless. If you had water in a server, these servers cost more than $400,000 per server. $400,000. How many cars do you buy there? So if you have one leak in one of the tubes, you kill $400,000, unless if the server is on the top and then all the servers die. So it's $4 million. When you're using it, the electric liquid, even if you have a leak, nothing happens to the servers. You can actually pour this liquid on the server, nothing would happen. But that's one big advantage. The second big advantage is that you have to flow to bring in liquid only 15% of the amount you need in the single phase. So if you needed 4 liters per minute for 2000 watts, this liquid you'll only need half a liter per minute for 2000 watts. That's a huge difference in pumps, in tubes, in pressures, in everything. And eventually, in the cost of the power you need for cooling the data center. So data centers that used to be, for every dollar of computing, you use $1 of cooling. So if you have 1 million or 100 megawatts of power, only 50 megawatts goes to computing. With this technology, for every dollar of computing, you'd only need 5 cents of cooling. Meaning if you have 100 megawatt of data center, you can put 95 megawatt of that computing. Almost double the computing with the same power. Meaning much more revenue for the users, for the data centers.
Okay, well, aquí está un ejemplo. Thank you, Shahar. One last question. How long it takes to deploy this type of solutions? From zero to
Of course,
once you have up and running.
fast, but the reason is that the servers come fully deployment. The servers come fully deployed from the manufacturers already. All you need to do is have the rack ready with manifolds, so the servers can connect to the manifold, and that's about it. So I'm not downgrading it. You do need infrastructure. You need to put the condensers or in the bottom of the rack or in the end of the row and connect them to the server, to the racks, and then manifolds inside the racks, and that's it. And the servers come ready.
Okay. Bueno, thank you very much. Aquí tenemos una de las alternativas que estamos conociendo más aquí en Yotta 2025. Thank you very much, Shahar.
Thank you for stopping here.
Shahar Belkin, evangelista de Liquid Cooling.